Okay, this is a short video to make the knight move in our little chess continuous assessment. So if you've watched the other video, you already know that the knight moves in an L shape, and the value that we put on the knight as a piece is 3 in the point system. So we know that the knight moves in an L shape. So let's take a very quick look at our continuous assessment book. And you can see here this gives an example of the white knight here and the possible squares that the L shape allows this knight to move or to traverse to. Now we can see here that the knight is currently attacking, and because of that L-shaped movement, 3 of its own pieces. We can't allow that to happen. We can also see down here in the code that if the knight is going to move, and if we want to look explicitly at the number of possible squares, there are quite a number of options to be coded in. So what we're going to do is I'm just going to open up the terminal. I have it open, and the code that we have. So now let me just see. So if I compile the chess project and if I run it, currently when I try to move the knight, it's not programmed in to move at all. Okay, so step 1 of this process is to make that knight move. So I'm going to jump back to the code, and I'm going to add in the else, and then if I say if piece name dot contains knight, I'm going to set the valid move is equal to true. And as we've seen time and time again, if I close this instance that's running, recompile, and then run again, I now should be able to move my knight anywhere. But as you can see, the knight can take its own piece, and it can move essentially to any other square on the board. Okay, but as we know ourselves, that from an incremental development perspective, we've done the first move. So we have the valid move is equal to true. Now, if I was to say, we know that the knight can move in an L direction, yeah? So this is great, yeah? So what does that mean, yeah? Well, it means that if the X movement equals 1, then the Y movement must equal 2, yeah? And also the other way around, yeah? Okay, so in Java we would simply say if X movement equals 1 and Y movement is equal to 2, we say or X movement equals 2 and Y movement equals 1. Now we just need to tidy up some brackets here. So I'm going to group those 2 conditions here, and I'm also grouping the first condition here, the first set of conditions. And now to close off the if, I'm going to put an outer condition around it. And now if I put my valid move equals to true in here, and get rid of it outside, save it. So essentially what I'm saying here is if the knight is moving in an L shape, I recompile, run it. So now if I go to move it to this square here, which is like a bishop movement, or one square away, it shouldn't move. If I traverse straight down the y-axis, it shouldn't move. But if I move 2 in the y and 1 in the x, it's a valid L-shaped movement. So now we've come up with a little formula to allow us to get rid of statically looking at all possibilities and to be able to just simply move in an L-shaped movement. Okay, so this is great, right? Now, the only other thing is the knight doesn't need to look at what piece is in the way, okay? So it can jump over pieces. As we see here, this black knight here is surrounded with pawns in front of it, but it simply jumps to the square that it's trying to get to. So the condition that we need to consider is, we need to check the square that we are moving to, and make sure that if there is a piece present, that it's not our own piece. Okay, and that's all the knight does, okay? So let's have a look down here. So we get rid of valid moves equal to true. If we're moving in an L direction or an L shape, we need to say if piece present. We've already explained the if piece present, and e.get x and e.get y. And if we say if not piece present at this location, we can simply say the valid move is equal to true. Okay, let's take a little look at that. Okay. So we recompile and run it. This time, whenever I move it, if I land on a square that has a piece present, it simply says that it's an invalid move, even though that is moving in an L shape. 1 square in the Y and 2 in the X, it's an invalid move. Now if I move in 2 squares in the Y and 1 in the X, in this instance here, I land on a square where there's nothing, and it allows me to make that movement. Now, I shouldn't be able to take my own piece, however, I should be able to take an enemy piece. And as you can see, I cannot, or I'm unable to take the enemy piece. So if we jump back into this little condition here, we have simply now got 2 cases, right? So we have one case if it's a white knight and one case if it's a black knight. So we say here, if piece name dot contains white, else, okay. So simply what we're saying is if the piece name, which is the piece name up here that we're using, so the piece name that is being moved is the knight, and if the knight or the piece name contains the white, so it should be a capital W, a white knight, we need to make sure that the piece at the location is an enemy piece, yeah? So we would simply say if check white opponent at e.get x and e.get y, and if it's a white opponent, we say valid move is equal to true. And then in our else condition here, so this is the else, so if the piece name doesn't contain white, it must be a black piece. So then we simply say if check black opponent, and we pass in the parameters e.get x and e.get y. We say valid move is equal to true. So let's have a little recap of the code here, yeah? Okay. Okay. So we can see here, we say if we're moving in an L shape, that's cool. If there's no piece present, that's cool. And what we need to do is we need to close off this and make the valid move is equal to true, because we don't need to check the case underneath it. And else there is a piece present. Then what we need to do is we need to copy in this code here. So we say that if there's no piece present, just make the move. Else, we know there's a piece present, so now we say if the piece name contains white, check that it's a white opponent. If it is, valid move is set to true. Else, check if it's a black opponent. If it is, the valid move is equal to true. and then we simply continue on down. As we simply check our little brackets here, we seem to have an extra bracket. The compiler will tell us anyway, and we can just simply fix up our brackets. Oh, we do have a name problem here. We have on line 269 an error, can't find the symbol piece_name.contas. So in other words, we meant to spell contains with a C-O-N-T-A-I-N-S, or contains, white. And the useful thing here is we can see whenever you're typing here, you will make little mistakes and little errors, but you should be able to read what the output is saying. And it simply told me here on line 269 there was an error and I cannot find the symbol if piece name dot, and we can see the spelling mistake straight away. Okay, so if we save that, and now we recompile it, and now we run it, and we can see now, so the knight shouldn't be able to take its own piece, which it couldn't a minute ago, but now as we navigate down, we should be able to capture our opponent's piece, which we can. So similarly for the black knight should be able to move in L shapes and be able to take its opponent piece, but not be able to take its own piece. Okay, and as we can see here, we now have the knight moving like it should in L movements, not able to take its own piece, but able to take an opponent piece. And as you can see, the code snippet, if we look at using simply the L-shaped, or using the idea of the L-shaped, is simply a couple of lines long. It's very short. Okay, thanks for listening. Bye.